going to give you notes on angle measures in circles. You're going to hear me refer to this as the in, on, out theorems. Okay, we start with the in theorems because when you have a circle and you have two secants, their intersection is an angle that is inside the circle. Okay, this is not the center of the circle. If it was the center, then it would be a central angle, and we wouldn't need to go through all of this. All right, so if you look at how this angle was formed, if we follow these secant lines, this angle is formed and the secant lines intersect this arc and this arc. What I know is that the measure of angle 1 is going to equal half the sum of those arcs that are being intersected. It's like the average. So an example, very basic example, if I want to find the measure of angle 1, and this arc is 120, this arc is 80, this arc is 100. Okay? Well, first I can add up all of these arcs and I would get 300. So I know my missing arc is 60. And therefore the measure of angle 1 is going to equal half. Look at how angle 1 is formed. This angle, or this arc and this arc. 120 plus 60. So the measure of angle 1 is going to be 90. So those are the in angles. Next we have the angles that are on the circle. This happens when you have a secant line and a tangent line. Okay? Again, this is not going through the center of the circle. If you look at this angle, whose vertex is on the circle, the measure of that angle is going to equal half the measure of the arc that it is intercepting. Okay, so it's intercepting this arc right here. This angle is going to be half of this arc. Let's look at an example. Okay, if I give you that this arc from here to here is 230 degrees, then I can find that the measure of this arc right here is 130 degrees. So the measure of angle ABC would be 65 degrees, or half of this arc. Okay, so we have our inside angles, our on angles, and now the angles that are out of the triangle, in, on, and out. These are formed by either secant-secant, secant-tangent, or tangent-tangent. All right. For these, I'm going to start with the angle. The angle is outside, and I'm going to put some letters on my circle. All right. For these, the angle, which is outside of the circle, is equal to 1/2 the difference of the arcs. So if you see how this angle is being formed, it's intercepting this arc and that arc. It is half the difference, and it's the big arc minus the little arc. The theorem is going to be the same no matter which situation that you have. Let me put some letters in here. So my angle is going to be half. Look at how the angle is being formed. You have this arc and this arc. It's going to be the measure of the larger arc, CB, minus the measure of the smaller arc, CD. And in this last situation with tangent, tangent, same thing, my angle is going to be half the difference. Now if you look at how this angle's formed, it's intercepting right here, and this would be your big arc, and this would be your small arc. So it would be arc ACB minus arc AB. A fun fact, an interesting fact here, is that the measure of angle 1 and the measure of arc AB will always equal 180 degrees. Only in this case, when you have tangent, tangent, this angle and this arc will be supplementary. Okay, so you need to take these theorems and do the assigned problems